Welcome to my channel Educational Wisdom. Have you ever noticed why your face looks bigger in a shaving mirror, but smaller in a car's side mirror? Why does this happen? Today, we are going to discover the science behind this interesting effect by learning about spherical mirrors. First of all, what are spherical mirrors? Spherical mirrors are mirrors that are shaped like a part of a sphere. Based on their shape, there are two main types. The first one is the concave mirror, which is curved inward, like the inside of a bowl. The second one is the convex mirror, which is curved outward, like the back of a spoon. Before discussing image formation, let us understand some important terms related to spherical mirrors. The pole, represented by P, is the center point of the mirror's surface. The center of curvature, represented by C, is the center of the sphere from which the mirror is cut. The radius of curvature, r, is the distance between the pole and the center of curvature. The principal axis is an imaginary straight line passing through the pole and the center of curvature. The focus, or F, is the point where parallel rays of light converge in a concave mirror or appear to diverge from in a convex mirror. Now let us study image formation by a concave mirror. Concave mirrors can form different types of images. The image may be real or virtual, upright or inverted, magnified or diminished, depending on the position of the object. Let us look at different cases one by one. Case 1. Object at infinity. When the object is very far away, parallel rays fall on the mirror and converge at the focus. The image formed is point-sized, real, inverted, and formed at the focus. Case 2. Object beyond the center of curvature. One ray parallel to the principal axis passes through the focus after reflection. Another ray passing through the focus emerges parallel after reflection. The image formed is real, inverted, diminished, and lies between F and C. Case 3. Object at the center of curvature. The rays meet exactly at C. The image is the same size as the object, real, and inverted. Case 4. Object between C and F. The image is formed beyond C. It is magnified, real, and inverted. Case 5. Object at the focus. The reflected rays become parallel to each other. The image is formed at infinity. Case 6. Object between F and P. This is the beauty mirror effect. The image formed is virtual, upright, and magnified, and it appears behind the mirror. Now let us move to image formation by a convex mirror. A convex mirror always forms a virtual, upright, and diminished image, no matter where the object is placed. When parallel rays strike a convex mirror, they appear to diverge from the focus behind the mirror. The image is always formed behind the mirror, smaller in size, and upright. That is why convex mirrors are widely used for safety purposes. Now let us discuss the uses of spherical mirrors. Uses of concave mirrors include shaving and makeup mirrors, because they produce magnified images. They are also used as dental mirrors, in reflecting telescopes, and in car headlights and torches to focus light. Uses of convex mirrors include vehicle side mirrors, where objects appear smaller but a wider area is visible. They are also used as security mirrors in shops and as road safety mirrors at sharp turns. Finally, let us look at some important formulas. The mirror formula is 1 over F equals 1 over P plus 1 over Q. Here, F is the focal length, P is the object distance, and Q is the image distance. The magnification formula is M equals image height over object height, or M equals minus Q over P. This formula helps us determine the size and nature of the image. That's all for today's lesson. Thank you for watching. If you found this video helpful, don't forget to like, comment, and subscribe to Educational Wisdom for more easy and concept-based physics videos.